Hello! In this video, I'm going to demo the medical diagnosis validated pattern. The medical diagnosis pattern is more than just the identification and detection of pneumonia in X-ray images. It is an object detection and classification model built on top of Red Hat OpenShift and can be transformed to fit multiple use cases within the object classification paradigm. These use cases include detecting nefarious objects and packages at mail distribution centers, or contraband items hidden away in luggage at airports. The medical diagnosis pattern utilizes technologies from Red Hat and from other open source projects. At the core of the pattern is OpenShift GitOps, which is Argo CD, and it provides a GitOps controller to enforce the desired state of our applications deployed to our clusters. This pattern also utilizes technologies like Red Hat AMQ streams for Kafka, Red Hat OpenShift serverless for Knative eventing, and Knative serving functions, and the model storage is provided by Red Hat OpenShift Data Foundations, which provides a cloud-native solution for block, file, and object storage requirements. Secrets management is built into all validated patterns. Currently, the backend secrets manager is HashiCorp Vault. In addition to Vault, we use the external secrets operator to abstract the creation of Kubernetes secrets from the backend providers. The ESO also allows us to have flexibility with different backend providers. Medical diagnosis utilizes Grafana dashboards to visualize the pipeline and pipeline metrics. Let's get going on the demo. So we'll start the demo by logging into our cluster as kubeadmin. Once we get logged in, we're going to take a look at the installed operators. To do so, in the left-hand menu, click on Operators and then Installed Operators. We can see that we have a number of operators already installed on our cluster. This was achieved using the Validated Patterns framework for medical diagnosis. Now keep in mind that these aren't just the operators being installed. It's the operators, an instance of the operator, and the integration between the various operators that this application needs to run effectively. So now that we've taken a look at the list of operators, let's switch over to the developer context. So up at the top left, let's click on Developer, and then you can skip the guided tour. And then on the left, click on Topology. And then let's search for the project X-Ray Lab-1. When we zoom out, we can actually see the individual resources that are created to make up this application. Let's start the demonstration by scaling the image generator deployment config up to 1. We'll discuss why we're doing this in just a moment. In the Filter by Resource dropdown, select Deployment Config, and then in the name search for image. Click on the icon for image generator. And then click Details. Then scale the pod up to 1 by clicking on the up arrow next to the pod donut. Now let's jump over to the Grafana dashboard. So under the Filter by Resources, let's click on the dropdown and then let's select Grafana. Now we can see the Grafana instance, and so let's click on it, and then up in the right hand corner there's a little link or a little button that you can click on to jump out to the URL. So let's go ahead and click on that. And that will take us to our Grafana dashboard. So on the left hand side, let's click on the Grafana dashboard menu, which is a little 4-square icon. And let's click on Manage, and then let's click X-Ray Lab-1, and then let's select the X-Ray Lab folder. And this will take us to our dashboard. Because we don't have an X-ray machine to take these images, we emulate this with an application called Image Generator, which, if you remember, we just scaled it up. So using the dashboard as a reference, we see the X-rays in the lower left-hand corner. These are the images hosted in S3 that Image Generator places into the object store inside the cluster. That object store sends a notification to a Kafka topic, which triggers a Knative eventing function, which starts a Knative serving function that runs the risk assessment pipeline. On the right side of the dashboard, we can see the images that have been uploaded. Within these images, we get a timestamp, we get the user information, as well as some other identifiable information that's associated with the image. We also see the images that have been processed. And by process, that means that the AI ML model has actually looked at this image and is making a determination off of it or from it. And then finally, once the images have been uploaded and they've been processed, then they go through an anonymizer, which strips out all of the personally identifiable information, or PII, so that way they can be reused to train either the same model or another model in another facility. Just underneath the dashboard, we can see the distribution of images that the model has deemed normal. We can see that there are images that where the model is unsure if the image had pneumonia or not. And we can also see where the images detected a positive result for pneumonia. We can also see the CPU and memory metrics for the risk assessment container, which gives you a good idea of the compute resources that are going to be needed. And also in the center of that dashboard, we can see the number of pods running for risk assessment. Because we're using OpenShift serverless, we have the ability to scale up to meet demand, but we also have the ability to scale back down to 0 when that demand has been met. So to showcase that, let's go ahead and jump back over to our OpenShift console and scale image generator back down to 0. So jumping back over to OpenShift console, let's click on image generator and click the down arrow for the image generator deployment config to scale the pod down to 0. And then let's clear our filters. And now we can see from the topology view the pod starting to scale down. Now what we can do is take a look at risk assessment. So let's go ahead and click on risk assessment. And here we can see that it's got 2 pods still running. And that's because the image generator app is still sending images from S3 into the pipeline. And so until that stops, the notifications are going to keep coming. So as image generator is scaling down, those images are going to stop coming through and those notifications are going to stop. And we can see that by looking at the dashboard, and we can see that we're no longer sending any more images. And if we jump back over into the OpenShift console, we can take a look at risk assessment again, and we can see that one of the pods has already terminated. Now, this is part of the coolness that we were just talking about, where OpenShift serverless will scale up to meet the demand, and then it will scale back down to 0 when that demand has been met. So that's it for the demo. I hope that you enjoyed it. If you'd like to find out more information about validated patterns, please go to https://hybrid-cloud-patterns.io.